Welcome back to another video, and in this video we're going to be continuing on with our core data tutorial series. And in this particular tutorial we are going to be taking a look at how we can use a NSPredicate object to determine how we filter the results of a fetch request. So we're going to get started with our SwiftUI project, and what we are going to use. The method that we're going to use here of creating our fetch request is we're going to initialize our fetch request in an initializer rather than giving the property wrapper itself everything that it needs, because we want to be able, right, to give this thing some kind of search, right? We want to give this a search term. And we're going to do that in the initializer. So let's go ahead and go into Xcode here. And first things first, inside of our initializer, we're going to say search term string, right? Here, instead of saying state private var, we'll say var search term like that. And then in the initializer, what I want you to do is say self._projects equals fetch request. Here we're going to pass it an array of sort descriptors. There will be NS sort descriptor. We'll give it a sort descriptor with a generic type of project. We want to sort by the name. We'll say the order is .forward. Okay. Next, we need a predicate parameter. So predicate, and you can see this is going to be of type NSPredicate. It's optional because maybe you don't want a predicate. So by default it's nil, but we're going to give it a value here. We'll just say nil for now. And then finally, we'll have our animation parameter, and we'll set it to default. All right. Perfect. Now, let's take a look at the predicate here. So here, we are going to say, instead of nil, it'll be NSPredicate. And inside of this NSPredicate, we're going to have what's called a format string. So before I do that, though, I want to explain what a NSPredicate even is, right? So an NSPredicate is an object that allows us to specify how we want data to be filtered. Core data uses these extensively, so that's why I'm teaching it to you. And I want you to take a look in the description below. In the description, there is a link to a, albeit retired, Apple developer document. This document is called the Predicate Programming Guide. And inside of this collection of documents, you will find everything you need to know about predicates and working with them. In particular, I've linked the document where you can see all the different operators and placeholders that you can have in a predicate format string, because you're going to be using those quite a lot. And it's very important that you understand how each of these placeholders and format string operators and stuff like that actually work. Now, one thing you will notice in these documents is that the code examples given are written in Objective-C. The format strings remain the same in your Swift code, but all the code is written in Objective-C. And that's because these documents were written before Swift even existed, hence why they're retired. Apple has been pushing really hard for people to adopt Swift as opposed to Objective-C. And because they're so old, they decided to retire them. You can still access them, obviously, and they are still mostly relevant. It's just the code samples aren't written in Swift. So you'll have to parse some Swift. You'll have to parse the Objective-C into Swift coding, as opposed to the other way around. All right. So inside of our predicate initializer here, we will say format, and the format is a string. Now, anything after this format parameter is considered to be a value to be injected into the format string. For any number of placeholders you put in your string, that's how many extra arguments this initializer needs to take. This initializer is what we called a variadic initializer, where we have variadic parameters to work with. All right, so what we want is we want to be able to test to see if the name of any given project contains the search term that the user enters. And we can do this by using the contains operator of a predicate format string. And it looks like this. So inside your string, you'll say name, which is the name of the core data entity attribute we want to compare against. Contains. This can be lowercase or uppercase. It doesn't particularly matter too much. All the examples you'll see in the linked programming guide have the operators in uppercase, but they will work in lowercase. And then we need a placeholder for the search term. For strings and other objects, that is %at. If you want, for example, integers, that will be %d for digit. It'll be %f for floating points. Stuff like that. All right? So, with that, we need to pass it search term, like that. Just like that. Okay. Okay, NSPredicate format name contains %@, and then we'll pass it search term like that. Okay, there we go. Now we should be good to go. Now, let's go ahead, and the next step that we're going to take here is we're going to split our list off into its own view, and you'll see why in a second. So, inside of the body, let's take this, there we go, we'll boink, copy that, and then we'll say projects list. This will take in a search term of search term, like that. I'm going to create this as a new view here. Struct projects list. Have that conform to view. Var search term string. Just like that. We'll have @fetch request var projects as a fetched results of type with project as its type there. Var body sum view. Paste our list in there. I'm going to copy the environment property wrapper here. We'll paste that up there at the top in the event we need it. We're going to get rid of this property wrapper. @state private. So we're going to have a search term here for our searchable modifier. And this will then get passed on to our projects list. So the projects list will then get updated with the new results from the fetch request. And because we need our fetch request in that, other view, we're gonna get rid of this initializer here. All right, we're gonna cut that out. We're gonna go back down here. All right. Plop the initializer in there. Project. Okay. And we should be good to go. Let's check our issue navigator, just so we can fix any potential problems. Okay. Cannot find projects list in scope. Okay. We'll capitalize that. Okay. We'll say projects list. We'll pass it the search term. And we should be good to go now. Perfect. Now, you can see our content view is much leaner. And we have our list separated into its own view. Now, let me talk you through again what this is gonna do. So, in our content view, we have a searchable modifier attached to our projects list. This will allow us to enter a search term, and every time that state gets updated, as with any state variable in SwiftUI, the body property gets reevaluated, and with that reevaluation comes the projects list view gets re-rendered, and with that re-render, the initializer of project list reruns, therefore rerunning our fetch request with the new search term inside of its predicate, therefore giving us new results in the list. So, let's go ahead and save this and run our code. And we have a build failure, because why not? Okay. Yeah. Okay. I see. I did not initialize the search term in the initializer. I probably should have done that. Probably would have been smart. So we'll say self search term equals search term. Save, run, and we still have a build failure. What is it this time? Okay. Content view. We'll have to set that like that. And crossing my fingers. Okay, there we go. We have a successful build now. And here is our code. You can see, because we don't have a search term, everything is just empty. The table's empty, which probably isn't what you want, right? So what you can do is you can say, oh, we want this to be nil if the search term is empty, right, for the predicate. So we'll take a look at that here in a second. But let's search something. Let's say we want anything with the number 2 in it. Oh, look, our list now has stuff in it. So if we take a look at our list, we have project 2, project 12, project 20, and so on and so on and so on for every project name that has the letter or the number 2 in it. And that is perfect. That's precisely what we wanted. However, we need to fix that issue where it loads initially with an empty list, because no project name matches an empty string initially, right? None of them contain an empty string. So how can we do that? How can we fix this problem? Well, let's go all the way down to this view here. Go into its initializer, where we have our predicate. What we can do is we can say search term dot is empty question mark nil. Otherwise, return a predicate. So now, if the search term is empty, as in there's nothing in the search field, it'll return everything. Or at least it should, depending on what your fetch request exactly requires. If it's not empty and there is a search term, then we actually give it a predicate. And this is why the predicate parameter here being optional is so important. Because you want this to be nil if your search term is empty. If there is a search term, then you are going to want this to have a predicate attached to it. It just, of course, how you go about implementing this is entirely dependent on how you structure your app, but I'm just getting you started. So if we run this again, now we can see we have all of our projects back. And that is exactly what we wanted. All right, so with that pretty much does it for this video. Thank you all so very much for watching, and we'll see you in the next video.